triple CFTR modulator therapy for cystic fibrosis. Definition: cystic fibrosis is a more frequent autosomal recessive disease in Caucasians and is caused in a mutation of the gene that encodes the transmembrane conducting regulatory protein.
Inside your lungs, you have the bronchial tree. This carries airflow back and forth. In people with CF, the lungs contain long, thick and sticky strands of sputum. This clogs your lungs and becomes an ideal home for bugs. Dornase alpha, also called DNase and pulmozyme, helps you to get rid of the sputum. When taken regularly, DNase will chop up the thick strands of sputum into smaller pieces, making it easier for your lungs to clear. DNase is a subtle helper. It doesn't make you cough a lot, and you probably won't feel any immediate difference, but throughout the day, you'll be clearing and swallowing small amounts of sputum as your body moves it away from your lungs into your mouth. Over time, this helps to keep your lungs healthy and protect your lung function. If you don't take your DNase regularly, then the amount of sticky sputum may increase and become too much for the treatment to clear properly. If sputum sits there, then infections are more likely and that can result in damage to your lungs. So remember, you may not feel DNase working, but it's doing its job.
Application in medicine. The transmembrane conductance regulated protein regulates the passage of chlorine salt of water in the epithelial cells. Its alteration leads to anomaly in the transport of ions to the patient, produce a thick and viscous mucus which obstructs the ducts of the organ where it's located. Pros and cons. Pros. People have a better quality of life, living more than 4 years, something that was impossible before. Cons. It is likely that as they are having results of this and other new molecules is necessary and molecular combinations of this according to the mutation of ersithine in each patient.
The first CFTR modulator that was approved for people with cystic fibrosis was ivacaftor, also known as Kalydeco. This treatment alone helps people who have one of 10 genetic mutations that are seen in about 8% of people with CF. Ivacaftor lumacaftor, also known as Orkambi, is a drug combination that treats people with 2 copies of the F508del mutation, which is seen in about 48% of people with CF. Researchers are looking for ways to improve the performance of CFTR modulators for all people with just 1 copy of F508del. This would cover an additional 38% of people with CF. Researchers are doing this by stabilizing the defective CFTR protein so it functions correctly. When making a normal CFTR protein, messenger RNA, the long strand at the bottom, holds the genetic code and gives instructions for how to make the protein. The round structure is called a ribosome, which reads the instructions from the RNA and assembles the CFTR protein. The protein is made up of building blocks called amino acids, and these form different structures called domains that fold together like a puzzle.
Issue applied in Ecuador. It has an incidence of 1 per 2,050,600 newborns depending on the region and ethnic origins.
CFTR protein stands for cystic fibrosis transmembrane conductance regulator. It's a pore on the cell surfaces of many organs in the body, including the lungs, sinuses, pancreas, and the gut, that's responsible for the movement of salt and water on these cell surfaces. The cell surfaces need the salt and water to keep regular health, and is a problem when not functional in cystic fibrosis. When it's not functional, we have a loss of normal function, and that results in several downstream problems, including reduced clearance of mucus and a lot of inflammation, which cause damage to organs in the body. The abnormal protein function is due to mutations in the genetic code, or the information which encodes proteins, known as DNA. When the DNA is faulty, it results in abnormalities of the protein function at various different levels. There's a wide range of work being done in the cystic fibrosis community to address the problem of faulty CFTR protein function. This ranges all the way from clinicians to basic science researchers who are looking at ways to understand the protein malfunction and researching new drug therapies which target various mutations which cause different problems of protein function. As you can see, this is a very central problem and a very central focus for the cystic fibrosis community, and therefore the entire range of specialists in this field are being employed to help with understanding these problems. I'm very excited about the triple combination modulator trials for a greater number of patients with different CFTR protein and gene mutations. One important aspect is reaching patients that have one copy of the mutation F508del CFTR. These patients heretofore have not had CFTR modulators that would help them to restore health. With the next generation modulator program, which is under development now, we think we'll be able to reach patients with one copy of this F508del mutation and effectively help them with health, along with the patients who are already being helped with two copies of the F508del mutation.
Conclusion. FQ is an autosomal recessive monogenic disease that is an example of what could be a well-situated disease to benefit from personalized medicine.
A patient with cystic fibrosis is susceptible to infections of the lungs. This is due to a mutation that affects a protein on the surface of lung cells. Many different mutations can cause cystic fibrosis, but all of them involve a transmembrane protein called CFTR that functions as a channel for chloride to move in and out of cells. In this case, CFTR is less able to transfer chloride ions out of the cell compared to the functioning protein in people without cystic fibrosis. The channel is, in effect, locked shut. This inability to transfer chloride ions has an effect on the outside of the cell. In people without cystic fibrosis, there is a balance of chloride ions inside and outside lung cells, which maintains the right amount of water and salt ions in the mucus lining the airways. Cilia normally sweep the watery mucus from the lung lining, keeping the surface clean. In patients with cystic fibrosis, chloride ions concentrate inside cells and draw in water by osmosis. With less water, the mucus becomes thicker and cilia can't move. Flow is reduced, providing an environment for bacterial infection. But there are now drugs that can help patients. To find a drug, researchers tested over 200,000 small molecules to see if any would bind to the CFTR protein. Then, for each small molecule that had some binding ability, researchers chemically synthesized different variations of that molecule and tested them for the ability to improve the function of some types of mutant CFTR channels. They identified a drug that, when taken by patients with a certain type of CFTR mutation, binds to the CFTR protein, opening the channel and allowing improved ion transfer.